Now, these are the various types of IPv6 address. One thing you immediately notice that there is no more broadcast address in IPv6, because I guess they found that IP broadcast is too annoying. So in IPv6 we still have the idea of a unicast address, whereby a single IPv6 address is meant for a single interface or host, and we will have the IPv6 multicast address, whereby a single IPv6 address is meant for a group of users. And something new in IPv6 is what we call anycast. Now, in the old days, if you are companies like YouTube, where you have a lot of servers spread across the global footprint, providing some kind of internet services. Now, what we normally do in the IPv4 world is that when a user make a request to a certain website, let's say youtube.com, okay, so what happens is, depending on the user's IP address, the DNS server will give the user the nearest IPv4 server address to go to. Now, in IPv6, we don't have to use all these tricks to direct the users to the nearest server. Anycast allows all the servers to have the same global IPv6 address, and when a user wants to contact this anycast address, the nearest server with the IPv6 anycast address will be directed to. So the user will be directed to the nearest IPv6 server. Now, IPv6 unicast address comes in a few flavors. So you have your global address, means it's a proper legal internet IP address, and it starts with this range, and it's normally assigned by INA. Now, just like IPv4, we also have a certain range of IP addresses that are reserved, okay, to be used by IETF for future development. Likewise, we also have the idea of private IPv6 addresses, starting with FE08. So these addresses are private, so you use it locally within your organization, and it will never be seen on the IPv6 internet. Other IPv6 unicast address is what we call the loopback address, as well as the unspecified IPv6 address. Now, the IPv6 unicast address or the anycast address have this concept that certain range are set aside for certain functions. So for example, from this range to this range, this what we call the ISP prefix. So you can subdivide into different service provider, and each service provider being given a IP address can then subdivide it into different customer sites, and then each site can be subdivided into different subnets. Now, as you can see, the roles and responsibility of each section for subnetting is well defined. This range is for creating subnets, this range is for subnetting the sites, this range is for subnetting the prefix. Okay, so as compared to IPv4, in the IPv4 world, when you cut an IP address into smaller slices, it's very messy. So you can have class A subnetted to class B subnetted to class C, you know, many different ways of cutting an IP address. Here, it has a more structured way of subnetting, if you want to call it. So certain ranges are meant for certain roles and responsibility. So your subnetting range is fixed. This range is for creating subnets. This range is for subnetting the sites. This range is subnetting the ISP.